for my second block, you might want to fast forward through the first part of this, unless you just want to review. It shouldn't take me long to go through these first couple of slides. But for third block, you're going to want to listen to all of them. So when we are looking at our measurements, there are rules for our operations that we use with our significant figures. In other words, when we are adding, subtracting, multiplying, and dividing our data, there are rules as far as what can you keep in your answer. For example, if you are calculating the density of something and you have measured the mass in grams and you've measured the volume in milliliters, those two measurements are not going to have traditionally the same precision. So when you calculate the density, which is the mass divided by the volume, your ending number, as far as your calculation goes in your answer, can only be as precise as the least precise measurement that you made, which is typically going to be your graduated cylinder. So there are rules when you're multiplying and dividing and when you're adding and subtracting. So first of all, we'll go through multiplying and dividing, and then we'll come back to the adding and subtracting. Example 6, under multiplication and division. When you simplify the expression, as you see right there, you're going to get results that look like this in your calculator, if you do it correctly. Now remember, when you are putting this in your calculator, make sure you're following your order of operations and that you multiply these two and have them in their own common set of parentheses. So what you have to look at is that each of those numbers are measurements. So the first one here is 1.25 has 3.
Teachers, please excuse interruption. We are still testing the intercom system. Overlook any future interruptions for the next few minutes.
Okay, so you have 3 significant figures in that measurement. In this measurement, you've only got 2 significant figures. In this one, remember, beginning zeros do not count, so you have 4. Oops. You have 1, 2, 3, 4 significant figures in that measurement. And then the final one here, you have 1, 2, 3. Because of that final decimal, there's 3 significant figures. So your least precise measurement is going to be this one. So that is what you have to match in precision when you express your answer. Now, one thing that you want to remember is that these zeros are placeholders. You cannot start counting what you're going to keep until you get to your first non-zero digit, which here is 2. So you can keep the 2, the 0, and everything else gets dropped. Okay? Now, if this 3 or anything 5 or above, it would round that previous 0 up. But since it is not, we keep it as it is. And your answer is expressed as 0.020. 2 significant figures to match the 2 significant figures in the least precise measurement. Now, the next one has to do with dimensional analysis. And we will not get into that too much until we get into our chemical quantities, but when you have dimensional analysis, you actually have conversion factors, and those conversion factors do not affect significant figures. This is a conversion factor, this one is, and so is this. So none of those have any effect on your significant figures. So therefore, anytime you are converting from one unit to another, through dimensional analysis, the only thing that will affect your ending answer is what or how many significant figures you have in that first initial measurement. And here in the scientific notation that you see there, you have 1.24 times 10 to the 24th, the 1.24 are all significant figures, so therefore all of those count as significant. So when you get your ending number in your calculator, it comes out to be this. you can only keep 3 significant figures because you have 3 that are right here. So you have 3 significant figures in that measurement. So I can keep this, this, and this. That means that I will drop the rest of these, but keep in mind that that 9 rounds the 5 up. So I express my answer as 136. Okay? So when we're looking at multiplication and division, you are looking at the fact that you're looking at how many significant figures you have in your least precise measurement, and that's what your answer is going to match. Okay? Now, let's look at the examples here. Oh, right here is your answer to that question. When multiplying and dividing, you record the answer with the same number of significant figures as the quantity with the least sig figs in your calculation. Okay? Now I want to go ahead down here to the addition, and this should not say addition and division. This should say addition and subtraction. So sorry for that. Make sure you correct that on your notes. Adding and subtracting. So when you add and subtract, you're actually looking for how many places past the decimal are in the least precise measurement. So for example, when you add 94.45 plus 15.9, you get 110.35. Now, the age-old question, how many places past the decimal place do you want me to keep? This is answering this for you. So you're looking at your measurements. This measurement has 2 places past the decimal. This measurement only has 1. So this is what you're going to go by. So therefore, in my answer, I can only hold 1 place past the decimal, and I drop whatever else is there. Since that's a 5, it will round that up to a 4. So I express that as 110.4. Looking at the next one, 42.15 has 2 places past the decimal. 39.85 has 2 places following the decimal. Now, in this instance, when you take these and you do your subtraction, you get 2.3. That is not as precise as your 2 measurements were, so you have to match the precision. So since you need 2 places following the decimal and you only have 1, you've got to add in a 0. So this would be expressed as a 2.30 to match the precision of both of those measurements. So when you are subtracting, you record the answer to the place value of the greatest uncertainty. So this goes with the additional sheet that I handed out that says rules and calculations at the top, multiplication and division section at the top, then addition and subtraction. So when you are looking again, I wanted to bring into place the many places rule. This is another way that you can remember this. So for many, you're going to match your M. So for many and multiplication, for multiplication division, you're going to go by how many significant figures there are, and it's always going to be in your least precise measurement. Multiplication and division, how many sig figs in the least precise measurement. So when you, and all of these have what the calculator is going to tell you. So 6.38 has 3 significant figures. So 6.38 has 3 significant figures. 2.0 has 2 significant figures. So you have to go by that measurement and hold on to 2. You always start counting with your first significant figure. So 1, 2. You can drop these, but the 7 is going to make that round up to a 3. So this is recorded as 13. So in this first calculation, you have 3.24 meters. That has 3 significant figures. times 7.0 meters, which only has 2 significant figures. This is going to drive what we can keep in our answer. So your calculator says 22.68 meters squared. You can only keep 2 significant figures, so you're going to keep that one and that one. And you're dropping these. The 6 will round the last one up to a 3. So your answer is expressed as 23 meters squared. Okay. The next one, 100.0. Since that decimal place is present, then you have all of those zeros counting. So 4 significant figures there and 3 in this one. So this is the measurement that will determine what you can express. So you can only hold on to 3 significant figures. 1, 2, 3. Drop everything else, and that 9 is going to round that 1 up to a 2. So that is reported as 4.22 grams per centimeters cubed. All right, the next one here. Okay, looking at the 4th one down here, or no, the 3rd one down. This first 0.02 centimeters, you've only got 1 significant figure in that measurement. So that one only has 1. This one has 4 significant figures. So this is the one you're going to go by. So your answer can only have 1 significant figure. Now remember, you cannot start counting until you get to your first significant figure. That's not significant. That's not significant. This one is. So everything else gets dropped, but the 7 will round that up. So this is expressed as 0.05 centimeters squared. Number 4 down here, you have 710 meters. 710 only has 2 significant figures. Remember that 0 does not count at the end. So this one has 2. And 3.0 seconds has 2 as well. So both of those have 2 significant figures, therefore your answer should have 2. Now when you're looking at this, you know you're going to keep the 2, you know you have to keep the 3, okay? You know you have to drop these, and you have to drop that 6 after the 3. However, okay, sorry. So you know that when you have 710 divided by 3, there's no way, if you were to express that as 24, like I see a lot of times, there is no way possible that that is the answer to that question mathematically. So here, if you have a number that is a part of the whole number that can't be expressed as significant, you drop it and you replace it with a 0. Okay? But that is going to, that 6 will round this up. So 240 is what your answer should be, meters per second. All right? The next one, 1,818.2, that has 5 significant figures. 3.23 has 3. This is what you're going by. So therefore, you have 3 significant figures in your answer. 1, 2, 3. And once again, that 2 is going to have to be dropped and replaced with a 0. And the rest of this gets dropped. So that is recorded as 5,870 pound-feet, which is a force unit. Okay? So if it is part of the whole number and you have to drop it because of significant figures, you have to replace it with a 0. Because at this point here, that 0 just serves as a placeholder. And the last one, 1.030 grams, has 4 significant figures. 2.87 has 3. So you're going by this. You need 3 significant figures. So 1, 2, 3. That 6 will round the 5 up and drop the rest. So this is expressed as 2.96 grams per milliliter. All right. The second part of the many places rule is the places part and dealing with plus minus. So for your places, for adding, which is considered to be plus, and subtracting, you go by the number of places past the decimal in the least precise measurement. So, or let's just say past the decimal in general. I'll just take this part off. So we're not really worrying about our least precise measurement here. You're just going to go places past the decimal, and that's it. So when you're looking at the example problem here, you've got 6.8. Here you have one place past the decimal, plus 11.934. That you have three places past the decimal. So this is the one we're going to use, showing only one place past the decimal, and so you can only keep the 0.7 and drop everything else. So that is expressed as 18.7. So number 1 down here, this one has 2 places past the decimal. This one has 1. So you can only keep 1 place past the decimal, which is the 2 there. So this is expressed as 10.2 meters. Number 2, this has 1 place past the decimal. This one has 2 places. So you have to go by the 1 place past the decimal, which is the 0.2. The 7 will round it up, and it gets dropped after it rounds it up. So that is 76.3 grams. Number 3, you have 2 places following the decimal. For this one, you have 3 places after the decimal, so this is the one you keep. And you hold on to 2 places following the decimal, and you drop that 1. So this is expressed as 2.39 centimeters. For number 4, you have 1 place past the decimal. Here you have 3 places past the decimal. You're only going to hold on to 1 place after the decimal, which is the 0.2 here, and you drop the rest. So that is 709.2 liters. For number 5, you have 1 place past the decimal there, 2 past the decimal there, so you're looking at this to show you. So your answer can only hold 1 place past the decimal. The 7 drops, but it will round that 5 up to a 6. So that is expressed as 1,821.6 pounds. And then last one, number 6. For this measurement, you've got 3 places past the decimal. For this one, there's 3 places past the decimal. They both have the same precision. This answer that pops up in your calculator does not quite have that precision, so you've got to add a 0 in there to make it have 3. So this is expressed as 0.160 milliliters, because it's got to match the precision of the measurements that were taken for it.